Hey folks, just a quick one. All right, so in the email I'm mentioning to you to go to this website. So it's fchartsoftware.com/EES. So that stands for the Engineering Equation Solver. So this gives you some basic information about it. And what you want to do is download the demo. So you download the demo. You have to put in your information. I've already done that. Once you do that, it tells you to download it. They want you to put it in a particular directory. It's not really critical, but let me show you. I put it in, I did it in my documents. You could do it in your downloads directory. So here's they tell you to create an EES install directory. Inside here is the setup, and once it's done, you'll be able to run the software. I'm not sure if it already installed it for me, or do I have to rerun it each time? I might need to run it each time. Yeah, all right, so I already have it installed. So once you install it, it'll show up in your program file. So I'm going to go ahead and open it. All right, so this is the software. It's a demo version, but it's not really going to matter for you right now because we're just going to use it for the thermodynamic property data, the steam tables. Let me show you. Go under examples, go to properties, thermodynamic, and the example problem that you want is the property calculator. So click in here and say OK. So this is the equation window down here. You can actually just shrink it down. We're not going to look at it, but obviously this is the thing that we're going to be interested in. So let me bring over the actual table. So say here we're in the superheated water table. So let's choose one. I'll say the temperature here. So in this case I'm using the SI system. The fluid I'm going to use is steam. And let me make this smaller so that I can show you the steam tables as well. So let me put this over here and move that up. Okay, so I'm going to use this superheated water. So let's choose one. So we're going to say the temperature. I'll start with the temperature, and I'll say the temperature is 400. So I'll choose temperature in degrees C. So this is 400, and say I know the entropy. So I want the entropy. So I say I have the entropy. I'm looking for, say I'm looking for the enthalpy. So I'll put in 7.467. So 7.467, and I'll say calculate. So it tells me that the fluid is in the superheated region, and in this case it's going to tell me that my enthalpy is, it says 3264.5, and then indeed that is what shows up on the chart here. All right, so we're cooking with gas over here. So if we go to the saturated water, say the temperature table, so let's choose 230. And say we actually know the pressure as well. So let's do the pressure. And they want the pressure in kilopascals, which is nice because that's what we have. And we're doing 230, so we'll do 2797.1. So 2797.1, and we'll say calculate. So this is, so where we are, 230. So the saturated, it tells us that the fluid is in the superheated region. It's because it thinks that we are in at the fully vaporized side. So if I look for the entropy, we should be over here at 6.213, right? And if I look here for the saturated vapor, for the enthalpy, it's 2802. And then I could come in here and say I want to reduce the pressure a little bit. So, or even better, you know what I'm going to do? I'm going to say let me let the entropy be close to saturated, but not quite there. Let me say 240. So I move my entropy down to 2.7. How about that? That should put me all the way out the other side of the diagram. So 2.7, and I'll calculate. So obviously my quality here is like 0.2. So now if I plot the TS diagram, you'll see that I'm plotting over here. And you'll notice that the dotted lines are giving you the constant specific volume, and the black line is your constant pressure. All right, so much easier than doing everything looking up in the charts.